The Moon is Earth's only natural satellite and its closest neighbor in space. It most likely formed after a Mars-sized object collided with our planet billions of years ago. That catastrophe turned Earth into a molten sphere, and the material ejected into space eventually cooled and took on a round shape. Today, this crater-covered body orbits our planet, causing the tides in the oceans. The Moon's diameter is a little more than a quarter that of Earth, making it the fifth largest natural satellite in the solar system. The Moon goes through several phases: new moon, full moon, crescent, first and last quarter. But no matter the phase, it's hard to mistake our satellite for any other object in the night or even daytime sky. Now imagine waking up at night and noticing that the Moon looks unusual, brighter, and bigger. Half asleep, you don't pay much attention and lie back down, unaware that Mercury has taken the Moon's place. Mercury's surface, that of the closest planet to the Sun, resembles the lunar landscape, covered in meteorite craters. In size, Mercury is about 2/5 of Earth and slightly larger than the Moon, so its influence would be stronger, nights would be brighter, and tides and ebbs much more intense. The lunar, or rather Mercurian cycle, would shorten by about 14 hours. Overall, such a replacement wouldn't dramatically affect Earth. Now imagine Venus replacing the Moon. Venus is the third brightest object in the sky after the Sun and Moon, and is often called Earth's sister because their sizes and masses are nearly identical. In our sky, Venus would appear as large as Earth and shine far brighter than the Moon. It reflects 6 times more sunlight and would cover at least 16 times more sky. Nights would be as bright as early twilight. Through a telescope, one could see blurry swirling patterns in its yellowish-white cloud cover. However, Venus wouldn't become Earth's satellite. The two planets would orbit a common center of mass, and the orbit would be unstable. If Venus moved at the same speed as the Moon, the planets would eventually collide. If Mars took the Moon's place, the change would be obvious. Mars is twice the size of the Moon and has a distinct reddish disk with dark patches. Even without a telescope, its unusual color would be easy to spot. Mars is smaller than Earth, but much larger than the Moon, so the balance of forces would be disturbed. Tides would become so powerful that enormous waves, similar to tsunamis, would crash onto coastlines. Nights would be brighter, and landscapes would take on an eerie red tint. Through a telescope, you could admire Olympus Mons, the tallest mountain in the solar system. Over time, Earth and Mars could become a double planet system. Now imagine Jupiter in place of the Moon. Earth would no longer be an independent planet. It would become a satellite of the solar system's largest giant. But before humanity's end, we would witness a breathtaking sight, a huge striped sphere stretching across the entire horizon, with yellow, red, brown, and white cloud bands swirling in its atmosphere. However, Jupiter's immense gravity would immediately trigger earthquakes, volcanic eruptions, and tsunamis. Earth would be stretched and compressed by tens of meters. Our planet does not move fast enough to remain in orbit around Jupiter, and within less than a day, it would crash into the gas giant. If Saturn replaced the Moon, the view would also be unforgettable. The golden sphere would span 18 degrees of the sky, while its famous rings would stretch from horizon to horizon. Earth would orbit slightly farther out than Saturn's moon Dione, but because Saturn is vastly more massive, Earth would become its satellite. It wouldn't maintain this orbit for long. Within a few days, our planet would spiral inward and collide with Saturn. Before impact, Earth would pass through the planet's magnificent rings, made of ice, rock, and shattered moons. Even if no collision occurred, Saturn's tidal forces would tear Earth's crust apart. Uranus and Neptune are icy giants similar in size, larger than Earth but smaller than Jupiter and Saturn. Replacing the Moon with either one would lead to similar results. Suppose Neptune appeared in the sky instead of the Moon. 14 times larger, it would look like an enormous bright blue sphere. The Sun would regularly disappear behind it, causing long solar eclipses. Neptune's mass is 17 times that of Earth, so our planet would become its satellite. Tidal forces would make waves 1,000 times stronger than those caused by the Moon and increase seismic and volcanic activity. Even global communications could collapse. Imagine two parallel lines. The lower one is Earth's surface, the upper one the boundary of the atmosphere. The shortest path between them is a vertical line. Earth, with its 6 sextillion tons of mass, acts like a giant magnet holding the atmosphere in place. The air's density creates drag, and a launching spacecraft must push through these dense layers, requiring enormous energy. Airplanes use the atmosphere to generate lift through engine thrust and wing shape. Spacecraft can't do this. Wings would be useless in space and too heavy for launch. The small wings of the space shuttle serve only one purpose: safe re-entry. The shuttle's engines are rocket engines. They don't need air and work like a released balloon flying opposite the airjet. To reach orbit, the shuttle needs tremendous thrust and vast amounts of fuel. Its 3 main engines, 2 solid fuel boosters, and massive external tank produce about 3.5 million kilograms of thrust. Using atmospheric lift like an airplane is impossible. It would require even more fuel, and Earth's gravity would still hold the vehicle down. To escape the atmosphere, an object must reach escape velocity, about 28,000 km/h. An airplane cannot withstand such speed, and the fuel requirements would be unrealistic. Scientists are exploring alternatives. One idea is a space elevator, a colossal tower, 35,400 km tall, made from ultra-strong materials like carbon nanotubes. An electromagnetic climber could reach orbit in about 5 hours, but no material strong enough exists yet. Another concept is a space tram, a vertical vacuum tunnel with magnetic levitation, accelerating a craft to near orbital speeds. However, it's unclear whether humans could survive such acceleration. A third option is an air launch system. This involves a gigantic aircraft with a wingspan of about 122 meters, lifting a small shuttle to an altitude of over 10 kilometers. From there, the shuttle avoids the densest part of the atmosphere and requires less energy to reach space. Richard Branson is already working on this through Virgin Galactic to carry tourists to the edge of space.